A very good morning to our dear viewers. You are welcome to today's segment. This is Homeschool Program, proudly sponsored by our beloved directors, Pastor Jackson Senyonga and Pastor Eve Senyonga. This program has been running from the time our students were told to stay home, okay? And it is going to continue running up to the time the schools will be open. So please, parents, keep telling the students to wake up early in the morning and attend to these lessons. Today's lesson is going to be from chemistry, as usual, from 7 a.m. to 8 a.m. We are going to be covering a segment in mole concept, and that is going to be Avogadro. Avogadro's law. That is going to be our point of emphasis today, okay? We started this topic and we said it is all about determining or counting the number of particles in a molecule, okay? Or in a compound or in a substance, okay? So that's what we are going to be covering today. But before I go far, we have been taking you through these lessons since last week, and now I've not taken time to greet my people. So I want to take a few minutes and say hi to my people. Producer, give me that slide. I want to take this moment and greet my mom. I have very many. I have Mami Amoti, Aboli, Adieri, Atoki, Muzea Puli, and Adieri, my Uncle Sam, Bill, Sanyu, Twesige, Alex, Peter, and others, all my sisters and brothers from Kadoma family. There are very many, so I will not pick one by one. There are so many. All teachers from Kodai School, and all teachers from all over the world, in this nation, in other countries, please, I say you are doing a great job. I know most teachers are teaching different platforms. I want to say hi to the people from Toro Kingdom. I want to say hi to comrades in the struggle, countrymen and women. I greet you all in the name of our Lord Jesus Christ. And I would like to advise you to continue staying home and stay safe. Okay? That is it. So those are the people I had to say hi in a special way. But when we go to our next slide, I want to say hi to the guys who have contributed much in my lifetime, what I achieved, what I went through at campus, high school. I want to recognize you guys. Roy Semboga, KJ, KP, Papa Were, Aine, Muzei Saimo, Obed, Ojambo, Chombo, Eddie, Michael, Saddam, Matthew, Rich, Rukwago, Patro, Etojo, Job, Jackson, Jimmy, Odoi, Kalibar, Alan, Umayo, Robert, Sparrow, Odox, Nasulu, Bachwa, Okot, Seksaka, Charles Masco, Amanya, Jude, Ashoka, Isaac, and many others. Luze Arthur, King Math, that guy is in Kitende, is doing a good job. Fahad, wherever you are. Activists from Nkrumah Hall, love you guys. Biology Elite family, I won't be able to mention the names. Group 6 family, Royal Chemist family, Mwesa and Mesa fraternity, Makerere alumni, Sam Winsel, Mr. Kansime, Nawangwe, and in a special way, I want to say hi to Sir Solomon Rwanyaga and Sir Apollo Tumusime. I love you guys. In my next slide, I want to show you something small, okay? In the next slide, there is something small I want to show you. That is my pie chart that God gave me. That pie chart, I have friends, I have people that I hate, I have people that hate me. Unfortunately, the pie chart is full of friends. That means I don't have people that I hate. I don't have people that hate me. That is good, and that has been the Lord. Okay? Away from that one, we want to move to our next slide and emphasize a few things before this lesson starts. I want to tell you, people who are viewing me, the students who are outside there, please, as you come near the TV, get a notebook, get a pen, get a functioning calculator. Okay? And please, if you have not accessed these slides that we have been teaching, so please go log in to our website. If you don't have the account, create an account that is on our website, www.kodaischool.ac.ug. Okay? You can also check on our top television page. The videos are there. For all the lessons we have been teaching here, you'll be able to access them and be able to learn. If you meet any challenge, drop there a comment. We shall be able to respond to you immediately. For those who have done so, we have responded to you, and we are so grateful that you were able to communicate to us. Also, please invite a friend, invite a sister, invite other. You can't learn alone. God will bless you if you have a loving heart. Okay, so we want to look at what we covered yesterday first, because now today we are going to look at Avogadro's law. Okay, but there are other laws that we have been covering. We looked at Boyle's law, we looked at Charles' law, yesterday we looked at Guy Laskar's law. Okay, in our next slide you can have a look at it, because this law is going to help us achieve today's objective. We have what they call Guy Laskar's law. The word might be complicated, but it is very important, so you need to take it. Okay, we said this was the third law in describing the behavior of gases. Okay, and we said this law states that when the gases react, they do so in volumes which bear a simple ratio to one another and to the volume of the product if gaseous, okay, provided the temperature and pressure are kept constant. In our very first lesson of looking at molecular theory of gases, we highlighted a number of things. We said in these laws we are going to be looking at the word volume, we are going to be looking at temperature, we are going to be looking at pressure, okay? We are going to be looking at volume, temperature, and pressure. And we say that different laws will come up varying different constants here, okay? We said the first law that varies volume with pressure, that one called it Boyle's law. The one which varies volume with temperature, we call that one Charles' law. The one which keeps pressure and temperature constant, we call that one Guy Laskar's law. And today we are going to look at what they call Avogadro's law. Also, in Guy Laskar's law, we looked at an example. In the next slide, you can look at that example. We may not be able to do it on the blackboard since we did it yesterday, but we can look at its solution and use it to explain the law. We said this law, for it, deals with volumes, okay? The volume only, this constant only, volume. So the rest are constant. They are not changing. It is only volume which is varying. And we said this law applies to gaseous molecules only. Equations that are completely involving gaseous states, they are the ones which we look at in Guy Laskar's law. And when you look at that equation, it is showing you hydrogen is reacting with chlorine, and we are producing hydrogen chloride gas, okay? Hydrogen gas reacting with chlorine gas to produce 2 moles of hydrogen chloride gas. Okay, according to Guy Laskar's law, we are saying we are going to look at the volume. So we ask ourselves, This one is which figure is here? We said it is 1. Because this one you can see it is just 1. If these molecules were 2, we would say we would put here 2. If they are 4, put here 4. But since there is no figure, it indicates that it's just 1. Okay? I told you the other time, if I put here this, and I said that one is an orange, how many oranges are there? I don't need to put here 1, okay? But if I put there this one and I say those are 2 oranges, you refuse, okay? That means if there are 2, I have to put a 2 here. So if you don't see any figure, it means it is 1, okay? Simple. And now we said this one, according to the question we are seeing there on our slide, it is saying that 100 cubic centimeter of hydrogen were burnt in excess chlorine, okay? 100 cubic centimeter of chlorine. This one was 100 cubic centimeter hydrogen, okay? So if one volume, that's what we start with, one volume of hydrogen, okay, produces 2 volumes of hydrogen chloride, okay? Remember we said that if you are weighing rice, you are going to cook rice, 1 kilogram is producing 2 kilograms at the end. That means 100 will produce 2 times 100. And that's what we are observing in our slide. Okay? Let us see that slide. That's what we are observing in our slide. We are seeing that now it is becoming 2 times 100 and we get 200. Okay? Let us move to our next slide and we see today's objectives. What do we need to achieve today? Having seen what we looked at yesterday, let us see what we need to achieve today. Okay? We need to make sure by the time this lesson ends, we are able to describe what is they call Avogadro's law. You can set it and describe it and be able to talk about it. Okay? Describing something means that be able to talk about that law or anything they say describe. Okay? So we should also be able to apply it. Okay? We should be able to apply it in different calculations. That's what we are going to be looking at today. So let us move to our next slide and see what is it. How does it state? Okay? In that slide we are seeing that Avogadro's law states that equal volumes of gases at the same temperature and pressure contains the same number of molecules. Okay? Equal volumes of gases at the same pressure and temperature contain the same number of molecules. Yesterday we looked at in Gay-Lussa's law, we looked at volumes. Today we are looking at molecules. So the similarity between Avogadro's law and Gay-Lussa's law is that they all utilize the figures that are written before the molecule. Okay? If I would write, for example, hydrogen gas reacting with oxygen gas to produce water. Okay? Gas. We said here, when you have 2 atoms here, you have 1, you put a 2 there. They become 2. When you have 4 atoms of hydrogen and you have 2 here, you put a 2 here. So we are going to use this equation to explain what we are talking about. Okay? In Gay-Lussa's law, we term these figures here to be the volumes. Okay? But in Avogadro's law, we term them to be molecules. All right? Here we can say that these are 2 molecules of hydrogen in Avogadro's law. In Gay-Lussa's law, we say that these ones are 2 volumes. Okay? Are you getting me? So in that slide, I want you to look at it very well. In our next slide, having an example, the next slide, it is showing you, give it in a full screen. It is showing you that 2 volumes of hydrogen combine with 1 volume of oxygen to form 2 volumes of steam. Okay? Water. Gaseous state, it is steam. Okay? 2 volumes of hydrogen combined with 1 volume of oxygen to form 2 volumes of steam. How do we interpret this one in Avogadro's law? In Avogadro's law, it becomes 2 molecules of hydrogen combined with 1 molecule of oxygen to form 2 molecules of steam. Just simple. Today, just where we had yesterday volume, today we're going to put there molecule. Okay? Where there was the word volume, we are going to put there the word molecule. In our next slide, we can look at also another reaction where we have hydrogen reacting with chlorine. This is a gas, and that one is a gas, to produce hydrogen chloride. Okay? Gas. That is a 2. Okay? That is a 2 here. 2 atoms of hydrogen, 2 atoms of hydrogen. 2 atoms of chlorine, 2 atoms of chlorine. That equation is balancing. So when we put that slide and we see how we can interpret it, how we can move it from Gay-Lussa's law to Avogadro's law, we see that 1 volume of hydrogen reacts with 1 volume of chlorine to form 2 volumes of hydrogen chloride. That is, when we put the word volume, we are referring to Gay-Lussa's law. When we change to molecules, we are going to Avogadro's law. We say 1 molecule of hydrogen reacting with 1 molecule of chlorine to produce 2 molecules of hydrogen chloride. That's what we look at. So, this law has brought very many things on board. We look at something they call, sometimes you are asked to find the empirical formula. After the empirical formula, they ask you to find the molecular formula, okay? And sometimes they give you what they call vapor density, and you don't have the molecular mass. So today I want to bring to you this. You say 2 times vapor density we get the relative molecular mass. Two times vapor density, we get the relative molecular mass. I looked at this one, I said it is very important we bring it in this chapter and we talk about it, okay? Because it is deducted in this law, Avogadro's law. Then when we go ahead, we see, here we can interpret this one by saying relative molecular mass will be equal to 2, it is twice the vapor density, okay? Also, when we display that slide, we shall see that it follows from Avogadro's law that if equal volumes of gases contain equal numbers of molecules, then the volume occupied by 1 mole must be the same for all gases. Okay? So we are going to use the word molecules. After terming here the molecules, we can be able to determine moles. Okay? If we say 1 molecule is combining with 1 molecule to produce 2 molecules. What if we change the word molecule to moles? And now we say here we have 0.2 moles. That means we are going to use the same principle. We say if 1 is producing 2, if 1 is giving 2. Now we say, what about 0.2? That means 0.2 will be 2 times 0.2. And this, I don't want to repeat it, that's what you have been doing, okay? I told you, if you have not been following, go back and watch all the videos. If you are unable to watch the videos, go and download the slides. All the work is there, all the answers are there. You'll be able to teach yourself, okay? That's good. When we look at that one, when you compare the two, it brings what we call the gas molar volume. Gas molar volume. And this is the volume occupied by 1 mole of a gas. Let me put that one here because it's very important in today's lesson. Anything I put on the blackboard, please take note of it. It becomes more important than any other thing. So you should always take note. I'm saying the gas molar volume is the volume occupied by 1 mole of a gas. 1 mole of a gas. Okay? We want to see the volume occupied by 1 mole of a gas. Okay? But this volume depends on 2 things. Is the reaction taking place at room temperature or at standard temperature and pressure? We looked at that one in our Wednesday lesson. We said STP, okay, which means standard temperature and pressure. STP means standard temperature and pressure. So 1 mole of a gas at STP is equal to which volume? It is equal to 22.4 liters. Okay? 22.4 liters. If we don't put that figure into liters, and we say, maybe we are given decimeters, we say it is 22.4 decimeter cubed. Okay? If this volume is not in decimeter cubed, it can be in centimeter cubed. So what will it be? It becomes 22400 centimeter cubed centimeter. Okay? That can be the figure. If they give you a question involving decimeter cubed, that means you run to this one and say 1 mole of a gas is equal to 22.4 decimeter cubed. If the question is having liters, you say 1 mole of a gas is equal to 22.4 liters. If the question is having centimeter, you say 1 mole of a gas is equal to 22400 centimeter cubed. Okay? I think that one is clear. 22,400. Okay? That is at STP. Also, we say that if not at STP, it can be at RTP. At room temperature and pressure. This one stands for room temperature and pressure. At RTP, we say that 1 mole of a gas will be equal to 24 liters. Okay? It will be equal to 24 liters. Take note of the 2. Here, at STP, it is 22.4. At RTP, it is 24 liters. If not in liters, you can say it is now 24 cubed decimeter. Okay? If not in decimeter, we can say it is 24,000 cubic centimeter. All right? So these figures are very important, and that's what we are going to be using today to calculate different numbers. We see how questions come requiring us to use that knowledge. Okay? On our example 1, it is saying, determine the number of moles. You determine the number of moles. Okay? Remember I said, once they ask for something, it goes on the right-hand side. And what they have given goes on the left-hand side. So they are saying doing gaseous molecules at STP. Gaseous molecules at STP. They have given us one, part A, as 1.2 decimeter cubed. Please display that slide showing the question. Okay, example 1. 1.2 cubed decimeter of nitrogen. Right, this one is of nitrogen. So they have given us what? The decimeter, and they have said it is at STP So those two things are important, STP and the decimeter. So we come here and say at STP 1 mole equals what? At STP 1 mole equals 22.4 decimeter cubed. You will say that 22.4 decimeter cubed of nitrogen. Okay? 22.4 decimeter of nitrogen occupies, okay, 1 mole. Okay? This one occupies 1 mole. If you don't put this one here, if you don't put this one here, you can put it here. That means if it appears at the end, here it will not appear. It is the same. You can say 22.4 decimeter cubed occupies 1 mole of nitrogen. You get me? This one occupies 1 mole of nitrogen. And we pick it from here because they have said STP and they are using decimeter. Then after this one, you say, what about 1 decimeter cubed? That means 1 decimeter cubed occupies 1 over 22.4 mole of nitrogen. Because if 22.4 are occupying 1, that means 1 will occupy 1 over 22.4. And that has been simple mathematics that we have been going through. Now we bring the question, what about 1.2 decimeter, cube decimeter, occupies 1 over 22.4 times 1.2, okay, mole of nitrogen. I told you to keep playing around with your calculators during your free time. So put in this and you get the right answer. Okay? That one becomes 0.05 moles of nitrogen. If you look at this one, this one becomes simple when you observe, when you have this one in your head. However, I said, don't struggle to put all this into your head. This one is always there in the question paper. At the first page or within the question, this one will always be given. So it is upon you to identify. But in most cases, it is given at the first page. In the question, you'll find the question as flat as how it has been. Bring back the question. Okay? The question can be like that. Saying you calculate, but they are not showing you what is what are the figures at STP. Okay? If you look at that slide, the question, if you look at that question, it is showing you, the question is on the next. So if you look at it, the question was not having this. But I've said once you identify that in the question, they are stating STP and they are stating decimeter. You go back to the first page and you read 1 mole of a gas occupies how many volumes, okay? Once you get the volumes, you'll be able to get the answer. So when you go to our part B is saying you look at 300 cubic centimeter of ammonia. So this one you can remove it. Okay? You can remove that one and put 300 cubic decimeter of ammonia. So we are looking at ammonia. One, they have said these things are at STP. At STP, we know 1 mole of a gas occupies 22,400 cubic decimeter, cubic centimeter, okay? Remember the question is asking for centimeter, is giving us centimeter. So even here we shall come and pick the figure that is in centimeter, and that's what we shall write first. We shall say 22,400 cubic centimeter occupies 1 mole of ammonia. Okay? 1 mole of ammonia. And now we go through the same chain of saying, what about 1 cubic decimeter occupies 1 over 22,400 moles of ammonia. Right? So here, after getting 1, now we bring our 300 cubic decimeter, we say occupies 1 over 22400 times 300. What do we get? If we put that one into our calculators, we shall be able to get the correct answer. I told you to always play around with your calculators so that during the lesson time, during the examination time, you just produce the answers very fast without facing difficulties. Okay? When we put this one into that one, we shall get 0.013 moles of ammonia. If we can look at this one, it is having the same steps. Okay? There is nothing new here. This is what we have been going through. We said once you are given any standard, you change it to 1. Then you'll be able to get your right answer. All right? So here, it is upon identifying, is it STP or RTP? If it is STP, is it in liters? Is it in decimeter? Is it in centimeter? Okay? So let us look at example 2. Let us look at example 2 and we see what is it requiring us to do. Because this example was giving us volume, requiring us to calculate for moles. So we want to look at example 2 because for it is going to give us moles and requires to calculate for volume. Example 2. If we look at example 2, it is giving us moles and requiring us to calculate for volume and mass. Okay? The part for mass, we learned it. It was one of the lessons we had this week. We were calculating from masses to moles. Also, we calculated from moles to masses. So that means that one is going to be easy for you. So let us look at what is it in it. Today, our emphasis is here. RTP, STP. The rest, we have studied them. All this on what we are looking at is trying to cover up the objective for application of Avogadro's law. That is the question. No? That is an example. Let us go to the question. It is on slide 20. The question is on slide 20. It is saying determine at STP the volume and mass of, determine at STP the volume and mass of 0.04 moles of 0.04 moles of hydrogen. So when you are given moles and they are saying you change these moles into, you change the moles into masses, okay? You change the moles into grams. You change the moles into volumes. So you need to go back to the basics. 1 mole is equal to how many grams? 1 mole is equal to which volume, okay? So you'll be able to get what you want. Here, the equation is not necessary as of now. The equation is not necessary. What is necessary is STP and the grams, the standard figures. So when we look at the word STP, and the question is saying you calculate for volume and mass. So let us begin with volume. The question is having STP. That means STP we can change to any volume we want here. They are not specific. So we begin with this one. 1 mole of what is the name of the gas? We don't say 1 mole of a gas. Okay? Then here we have to give the gas. It is hydrogen. 1 mole of hydrogen. Okay? Occupies a volume of, you can pick any, decimeter, centimeter. Let us use liters, since we have not yet used liters. We say that is 22.4 liters. 1 is occupying 22.4 liters, a volume of 22.4. Okay? So what about 0.04 mole of hydrogen? I told you at the start that once you start this topic very well, the rest is going to be easy. Okay? But however, if you come and start the topic in the middle of it, you find these things difficult. Okay? So please, if you're just starting to learn today, go back and first study the past work. Watch the videos, go to the website, download the slides, you'll be able to learn. Then you come to this segment. Okay? 0.04 mole of hydrogen occupies 22.4 for 1 times 0.04. Those ones will be the liters. Okay? Let us put that one into our calculators and we see what can we get. Okay? We shall get 0.94 liters. Okay? That is very simple. I would request for the slide 21 because the part for grams, we shall not take time in it. We have been doing it so many times. This is the new segment that we had to calculate for. 1 mole occupying that volume. Remember, it is at STP, and the volume at STP is that one. So we change 1 mole into 0.04, we get 0. Full screen. That one is 1 mole of hydrogen occupying 22.4 at STP. That one. We said that 1 mole of hydrogen weighs. What does it weigh? It weighs the RAM, the relative atomic mass. And the relative atomic mass, we first get it. But since it is hydrogen gas, now that one goes to relative molecular mass. We have to first calculate for the relative molecular mass. That's what we have. 1 times 2. We get 2. That means 1 mole of hydrogen weighs 2 grams. What about 0.04 moles? They weigh 2 times 0.04. And you end up getting 0.08. When we go to our next slide, we see another part. Okay? On our next slide, we see another example which is also requiring us to apply the same idea but in a different format. Okay? Example 3. Example 3 is that you calculate the relative molecular mass of Y. Next, molecular mass of Y, given that 0.8 grams of Y occupies centimeter. Let us remove this. I don't want to remove those standards because you are using them. However, I told you that in the examination paper, these things may not be within the question, but they will be on the first page. So remind yourself that, oh, they have talked about STP. That means I need to go and pick the standards. Okay? On our example 3, we see that 0.8 grams of Y occupy 560 cubic centimeter. 560 cubic centimeter. So this one is direct. What do you want? Okay? They have said calculate the RMM. That means you want grams. You change this one. You say 560 cubic centimeter occupy. No, you say weighs, because these ones are grams. Weighs 0.80 grams of Y. It is Y. You can say 500 cubic centimeter of Y weighs 0.80 grams. It is the same. Told you whether you put it here, whether you put it the other side. What we need, they are these figures, not the grammar. So here, once you have this one, you put it into 1 cubic centimeter. You say of Y weighs 0.8 grams. It is the same. I told you whether you write it first or last. What we are looking at, they are the figures. 0.8. Remember 0.8 was for 560. That means for this one, we shall divide by 560, and we say these are grams. Okay? So remember, the question has said at STP. Then go back at STP and pick the centimeters. Centimeters at STP, they are 22,400. You come and put it here. 22,400 cubic centimeter of Y. That means weighs 0.8 times 22,400 divided by 560, and these ones are going to be grams. So you put that one into your calculators and you get 32 grams. Okay? If you don't get this figure, please try to use your calculators very well or repeat the steps followed. Okay? And this is going to be the RMM of Y. That one is going to be the RMM of Y, and we shall say that that number we have finished calculating it. So let us look at the next slide. Give me the full screen of it, because it is having a question, a very big question. We have to look at it. It is having different segments. However, all of them have been covered. 0.2 moles of ammonia gas measured at STP were passed over. The equation for the reaction is that one. When you react ammonia with copper 2 oxide, you get copper plus nitrogen plus water. Okay? And that's how you balance it. The reason is why you balance the hydrogen atoms you're having. Okay? You look at the hydrogen atoms you're having, you look at the nitrogen atoms you're having, look at the copper atoms, oxygen. What do you begin with? You begin with the nitrogen atom. You have nitrogen atoms at the product side. You need 2. You put a 2 at where there is ammonia. So nitrogen balances. When you look at hydrogen, you have 6 at the reactant side. At the product side, you have 2. You put 3, they become 6 also. When you look at the product side, you have 3 of oxygen. At the reactant side, you have 1. You put 3 there, and everything will balance. So there are of copper 2 oxide used. Part. Part A. Part B, they are saying the volume of ammonia used at STP. 0.2 moles of ammonia gas measured at STP were passed over. 0.2 moles of ammonia gas measured at STP were passed over 1 cubic centimeter of Y weighs 0.80 grams of Y weighs 0.80 grams of Y. And this one is going to be the RMM of Y. That means weighs 0.8 times 22,400 divided by 560. And these ones are going to be grams. of copper formed. Let us move to our next slide there, and we see how we can do that number very quickly. Okay? Since we have covered all those parts, now let us look at the steps we need to follow to come up with the right answer. One, if they say that you calculate the number of moles, okay? You begin with the standard moles. You begin with the equation, okay? The first question is saying you calculate the number of moles of the copper oxide reacting with ammonia. And you have 2 moles of ammonia reacts with 3 moles of copper. You can see from above that 2 moles are reacting with 3. The figures which are written there to balance that equation, those are the number of moles. 2 moles are reacting with 3. What about 1 mole? That means 1 mole will react with 3 divided by 2. What about the 0.2 moles that we have been given in the question? It means to be 0.2 times 3 divided by 2, you get 0.3. That is 0.23, but is 0.2 times 3 divided by 2 moles of copper. You get 0.3. Part B is having what we have been looking at. Part B is saying the volume of ammonia used. Once we don't look at the equation, look at the moles. Have been given 0.2 moles. Remember, we said if we can come back to our blackboard, because we said that one have to look at it here, since it is what we are supposed to cover today. The rest we covered them, so that's how they can combine their questions. Okay, so you need to read everything, because they will not pick one question like this, not one segment. They will combine all the segments. So we want to look at that one, which is saying the volume of ammonia. Volume of ammonia at STP. Okay? At STP. Remember, they have given you 2 moles. 0.2 moles of ammonia. Now they want the volume at STP. You have been given moles, they want the volume at STP. I said, when they say they want the volume at STP, and they have not specified, they have not said that they want the volume in liters. For them, they want the volume. So it is upon you to either use liters, decimeter, or centimeter. Let us use decimeter, okay? You pick any that you want. You say, now, 1 mole of ammonia occupy 22.4 decimeter. Okay? 22.4 decimeter. Now we say, what about this number of moles? 0.2 moles. Okay? Of ammonia. That means this one will occupy 22.4 divided by 1 times 0.2. What will be our answer there? What will be our answer? Put this one into the calculator and you get the right answer. Be 4.48 decimeter cubed. Here it is decimeter cubed, or cubed decimeter. That one is going to be our answer of ammonia. That is going to be the volume of ammonia in 0.2 moles. Okay? 0.2 moles are occupying this volume. Okay? Since one volume was occupying 22.4, 1 mole was occupying 22.4, a volume of 22.4. Now, 0.2 moles are occupying that volume. I think we are together. That one is simple. Let us move to part C. Part C is saying you calculate for the grams, the mass of copper. Let's display that slide 26. Yes. We are saying that on that slide we look at moles, 2 moles. Okay? From the equation, you say 2 moles, they produce 3 moles of copper. Okay? From that equation, you see 2 moles of ammonia produces 3 moles of copper. That means 2 moles of ammonia will produce, you put that one in 2 grams. If there are 3 moles, that means they are 3 times 64. Then you say, what about 1 mole? 1 mole will say 3 times 64 divided by 2. Those will be the number of moles of copper. What about 0.2 moles? There will be 0. No, we are not supposed to say. On the product side, we are producing grams. Okay? That is when 3 times 64 times 0.2 divided by 2, we shall get 19.2 grams of copper. Just we do simple mathematics there. And that's what we have been doing throughout this week. Okay? I want to remind you, on our next slide, we have the exercise. Please display there the exercise as I remind them about a few things. Okay? I want to remind you that this topic is called mole concept. And we said in our very first lesson that mole concept deals with determining or counting the number of particles. That's why every morning I've been encouraging you to be with your calculators, because you are going to be calculating a number of things. Okay? You can't calculate these things without a calculator. All right? And I want to remind you that this topic is examinable and in different papers. Paper 1, objective. There are so many objectives requiring you to calculate for different things. Okay? These segments are set in in so many papers. So paper 1, objectives. Paper 2, structured and the essay part, you can find their question. Okay? In a practical, number 1 is all about calculations. Okay? They give you, you look for the theta values. After looking for the theta values, then you'll be able to get into calculation part. And there they will say determine the number of moles, determine the mass, determine the RFM, all things. Okay? So that is the exercise. And next, remind you to go to our website, visit our website. That is www.codehighschool.ac.ug. Okay? If you have enough data, go to top television page, be able to watch those videos. They are there. You'll be able to learn. Okay? That is it. Also, I told you in the beginning that if these lessons are becoming nice, that's what we always do at Code High School. Please come to Code High School. Go straight to the office of the head teacher. Ask for the position, register, and be able to learn in a good environment. Okay? We continue to thank our beloved directors, Pastor Jackson Senyonga and Pastor Eve Senyonga, for showing an outstanding spirit. Okay? Above all people, others, before even the ministry brought it clear that we should teach students through the TV, through the radios, but our beloved pastors had already started this program, and we are so grateful for this work. Okay? Finally, the last slide is saying the next segment we are supposed to go to was volumetric analysis. We are not able to look at it. Maybe next time we meet. I thank you for being with us and being good viewers. God bless you. I remain as Saul Chamanywa. Stay home and stay safe. Thank you.